Good morning, everyone. Thank you for being here. We appreciate you taking out the time, and hopefully everybody had a great evening yesterday and a great election party. We're here to talk to you about Manila, which is the file share service that OpenStack has. We don't want to make any assumptions. How many people in the room actually know what OpenStack is? Okay, that's a good crowd. Only 2 people, looks like. Don't.
Anybody go to Barcelona?
Oh, really? Nice, nice. So yeah, I mean, I just have like one quick slide on OpenStack, but we'll move through it fast, especially because we've lost 12 minutes already. My name is Anika Suri, and I'm a Technical Alliance Manager at NetApp. I manage the OpenStack and container partners that we have, SUSE being, of course, one of the major ones. And I'll let Cameron introduce himself.
I'm Technology Strategist for SUSE. I work on the West Coast in the USA, and been with SUSE for about 11 and a half years now.
Perfect. Thank you. So like I said, we'll briefly talk about what OpenStack is for people who don't know in the room. And we'll jump right into Manila. What is Manila? Why would you use Manila? The use cases for Manila that Camel walked through. We also have updates that came out with Newton 2 weeks ago, and we'll also talk about the new features that are coming out with the Okata release that's coming up next year, early next year. And we'll finish off with a demo of SUSE on NetApp storage, and that Camel will lead. Okay. So again, what is OpenStack? It looks like a lot of people in the room are already aware, so I don't need to go through the entire slide, but I'll just summarize for you. OpenStack is a cloud computing platform, which is mainly deployed as infrastructure as a service. It's written in Python, is very rich in RESTful APIs, and is gaining huge market momentum, as you'll see in the slides upcoming. It has a 6 months cadence, as I mentioned. The last release 2 weeks ago was called Newton. The one upcoming is Okata, and then we have Pike and Queens coming up next year. It follows, I don't know how many people know, but it follows the letters of the alphabet. So it started from Austin, A, and now we're at P, right, Pike. So it takes, like the names that are given to the major releases, they go by alphabet, the first letter.
And that's the new OpenStack logo, by the way, revealed in Barcelona.
That's true. Yep, they have a new logo as well. So like I said, we're in year 6, huge market momentum, as we'll see, right? We have close to 55,000 members because it's all open source, right? It heavily depends on developers and people in the community contributing. And this is a slide that was released by the foundation earlier this year, and it talks to about over 20 million lines of code that are written by people and over 600 companies that are involved, right, at any given point in time. So again, this just talks about momentum and where OpenStack is heading. It's kind of mainstream now, as opposed to a few years ago when we thought of it as like a science project. A lot of people did, actually. So today, OpenStack, as of 2 weeks ago, actually, to be accurate, OpenStack is deployed. Well, 71% of the deployments for OpenStack are actually in production, based on what the foundation released. And these are the accurate stats, which is about 20% more than what we had last year. So again, speaking to the fact that we're seeing it becoming mainstream, gaining huge momentum, seeing a lot of activity from all different kinds of market verticals. And that's where we are at today. A high-level architecture overview. I know most of you said that you know what OpenStack is, but we'll briefly just go over, because these are the major projects, and they will be referred to, their code names will be referred to in this upcoming slides. So I wanted to make sure that you're aware of the names. So dashboard is Horizon, orchestration is Heat, networking is Neutron, the Neutron project, shared file system is Manila, which is what we'll be talking about today. Block storage is Cinder, compute is Nova, image is Glance, object storage is Swift, telemetry is Ceilometer, and identity is Keystone, which is the authentication piece. So today, like I said, we'll be focusing on Manila, but going down the slides, we will be referring to other code projects as well, because apart from these, I mean, of course, OpenStack has a lot more projects, right? Like Magnum, Ironic. I'm sure a lot of you have heard of these or have dealt with these. Other upcoming projects as well. But these are the main ones, and that's why I had them on. So why is this important, or why is Manila important? Because 65% of the storage that's sold today has actually file-based use cases based on a research showed by IDC. And that's consistent with what we see in the foundation survey as well. We see Manila emerging as the 4th largest OpenStack project as of 2 weeks ago when this survey was released by the foundation, right next to Magnum, which is the container as a service, and Ironic. So these are good, important projects that are gaining a lot of momentum. I know NetApp is involved. I'm sure a lot of your companies and organizations are involved as developers or as consumers as well for these projects. So that's where Manila stands. And here is a quick breakdown from earlier this year on where the usage of the driver stands. And NetApp, as you can see, is about 23%, which is the largest chunk of the pie. And we've been a leading contributor and the most widely deployed option for Manila today. Okay, so moving into the meat of the session, right? What is Manila? How many of you have actually played with Manila or are aware of what it is? Okay, so no one. Perfect. So Manila is actually an OpenStack file share as a service project. It provides multi-tenancy and security. And for instance, in this slide, we have an example. If you have different tenants, right? Let's say tenant 5 and 8. What Manila gives you is the capability to have isolation between tenants. So you could have, access control lists, which are ACLs, or by specifying certain network address ranges, you can separate out different departments and different tenants so they have or don't have access to certain files, right? So for instance, if I had, tenant 5 and 8 belonging to different departments, such as marketing or, research or engineering, I could control which files tenant 5 has access to and tenant 8 has access to. So I could only give them access to a certain department, and the same for tenant 8. So basically it provides security, right? And it makes multi-tenancy super easy. So that's what Manila is in a chunk.
So the way you do it through access control list, like fencing or what?
Well, access control lists are access rules. So you can set up security rules in Manila, and you can set up IP address ranges. So for instance, groups. What kind of groups? Did you mean availability zones or?
No, like using groups to give access control to a group.
Yes, you can do that. Yes, you can do that. Yeah. So this was just, in this example, I just have a tenant, but you could also have a group of tenants. So these are a few key concepts of Manila. For instance, I refer to share, right? The share can be accessed concurrently by multiple instances, and that's actually the content, the share that you're trying to share between different tenants. So that's what a file share is called. Access control list, as I mentioned, right? It can be specified by IP and insider notation, and it defines which clients have access to what shares. A shared network, in the terminology that Cameron will be using, is basically, it can be associated with a single share network. And it's usually a neutron network or a subnet, but it can also be a standalone network, as you'll see in my next slide. And then also comes with the security service, with Manila comes a security service such as LDAP, right? And a share can be associated with multiple security services. And then we have snapshots which are read-only content copies of shares. And a new share can be created from a snapshot. So if you have a snapshot, you can actually go in and create a new share from that. And then you have backend and drivers, which are provider of share, which is backend, and then drivers are, for instance, NetApp driver, or you have other storage drivers. And what they do what they are specific vendor technology implementations of backend APIs. So the demo I think Cameron is showing you also has, you will be able to see a little bit of the NetApp implementation of the NetApp drivers. And CloudStack 7, which SUSE released about a few weeks ago, again has NetApp drivers inbuilt, NetApp Manila and Cinder drivers inbuilt into the distribution.
Just to be clear, these features are exposed to the Horizon dashboard for OpenStack. Okay.
Perfect. So moving on, just a little bit of a history for Manila, because it didn't look like everybody was familiar with the project. It was first, the talks for Manila came about in the 2014 timeframe, so about 2 years ago. And it was first submitted as an official proposal in the Kilo release. As I mentioned, OpenStack releases are by alphabet, right? So Kilo was the K release. And then, we had storage pools and different types of features that were proposed in that release. And then there was Liberty, and since then we have not looked back, right? There are different releases that come up with different, that have different bugs that are fixed, new features that are released. Some of them Cameron will be covering in the Newton section, for instance. And today with Newton, which was, like I said, released 2 weeks ago, we have about over 23 drivers that are part of the Manila project. And about 14 blueprints that were completed, with about 5 successfully accepted. And Cameron will be going into details of each of these, for instance, share migration. He'll be going into each of these in detail. And also at the top, you see contribution by companies. And NetApp has been the founder for Manila, one of the founders for Manila. And we're proud of the community involvement that we have. We have a lot of engineers who are actually devoted to coding and help our customers and our joint customers, with their Manila deployments. So these are the deployment options with NetApp Driver. You could have SVMs, which are single storage virtual machines, and based on the variable, which is called driver handle share servers, you could choose how Manila is deployed or how NetApp drivers are deployed in your deployment. SUSE, for instance, Cameron, correct me if I'm wrong, by default this variable is true for SUSE, which means that NetApp drivers will take care of the entire deployment. And if you have set that to false, then it's in your hands how you want to play with the driver, what settings you want to have, what flags you want to set as true or false. It's kind of up to you. In the deployment choices, you could either deploy the drivers directly or intermediately. If you deploy NetApp Manila drivers on a FAS system directly, it means that the drivers will be talking to the FAS unit. I'm hoping a few of you know what the FAS unit is. It has been NetApp's bread and butter. Cluster Data on Tap is the software that runs on them now. And if you have the direct mode, then the drivers are talking to the FAS system directly. And if you're running the intermediated mode, there can be a software entity in the middle that is talking to the NetApp driver and then talking to the FAS system. So basically, it's a sandwich. So there's a layer in the middle that's helping you talk. Two entities talk. The NetApp driver talk to the hardware. So these are different choices.
So can you do it in real life with reboot? Can you install the drivers in real life, all those plugins?
When you say real life, what do you mean? You mean in actual production deployment? Yes, of course.
Absolutely.
Yeah, so like I said, SUSE is already the variable is set to true, so SUSE is default with Manila drivers. Our other distributions, the other OpenStack distributions they do have NetApp drivers inbuilt. I don't know if I can say this, but Red Hat, for instance, has, their GAing has NetApp drivers as well inbuilt. So depending on which distribution you use, of course, you have access to them by default, or you can go in and download them from the NetApp Git.io site. Okay. And then in network plugins, you also have options, as I mentioned, right? Most of our customers actually that we see use the Neutron network plugin, but you're also open to using a standard or standalone network plugin or a Nova network plugin that OpenStack offers if you didn't want to use the Neutron plugin. And now moving on to the use cases, which is kind of the meat or the most important part of this session. I'll let it go to Cameron.
Thank you. Awesome. How many here have NetApp deployed? Nobody has NetApp? We've got one with NetApp. Okay.
I'm hoping the others will move soon.
NetApp reseller.
Oh, you're a NetApp reseller. Okay. Okay.
So,
Okay. All right.
good choice.
So there are many different use cases from a DevOps perspective to enterprise applications, database as a service with Trove on OpenStack, Heat deployments, hybrid cloud shares, and the list goes on and on. I'm going to dive in really quickly with a couple of these use cases. Standalone share file services management. Traditionally, we have legacy systems, people using NetApp today for their share file servers. And typically it could be NFS or CIFS running on Windows. So essentially today we want to take that use case and move that to the cloud. Okay? So this gives us that window of opportunity to take advantage of moving that to the cloud and take those use cases, those legacy use cases in your data center today, and moving that to Manila, running your workloads there in the cloud. This, of course, will also help improve some of your SLA running on top of OpenStack. So where you may not have used shared file services before on OpenStack, you can now use that today running on top of NetApp with Manila. Another use case, enterprise applications, porting those applications to using those shared file services that you had before. So you might have workloads today that are using NFS or using CIFS that you need to port over to a cloud environment. This just makes that much easier. Okay, so it is available and running on top of OpenStack. So you can run those same applications and port those over to OpenStack and have those same shares running on top of OpenStack. Digging deeper into DevOps, you now have the ability. So this is a pluggable infrastructure. You have the ability to do snapshots and clones. So if you have a Docker environment or some type of container environment running on top of OpenStack, you can take snapshots of your file shares and run those with your containers, with your container technology, whether that be on Magnum or just straight Nova with Docker. It works either way. You can plug in your containers to your Manila storage. And any questions on the DevOps infrastructure there? And where that plugs in? I think it's pretty straightforward from a DevOps perspective, really automating that with Heat as well, automating the launching of containers and attaching your file share services with containers. Allows for that continuous integration for your file shares. Sahara integration. Here's another use case on top of OpenStack. Sahara is fully supported with SUSE OpenStack Cloud version 7. This will allow you to use NFS, okay, Manila provisioned HDFS on top of NFS, offering you more options, right? So instead of having to use HDFS, you can now use NFS as well. So Manila will provision that out for you for your infrastructure with Sahara. So there's been integration testing done to make that happen for your Sahara environment. Is there any big data people here? Okay. So there's a couple of implementations with Sahara side, either using the NFS shares or the HDFS. So Manila would be able to provision either one out to your Manila storage on NetApp. Okay, so you can provision the NFS or you can provision the HDFS, purely integrated there for Sahara. Another integration point also, if you're going For file share services, there's also CephFS integration there as well. So you have lots of options. Yes?
Question about that last slide. So how are these actually exposed to the virtual machine instances? Is this a block device or like BirdIO 9T, the shared file system stuff that's available for BirdIO?
Yes.
How do they end up, if I was to look at an instance of one of these, what would I see then?
Yes, it's a shared file services instance that gets attached to the Sahara instance that gets provisioned. Yep. In the case of HDFS, it is a block layer that will get attached, right? So you have to provision the HDFS file system there on that block device. So that is communicated back to the cluster data on tap to provision that properly, and then attaching that to the Sahara instance that gets launched. Any questions further on that? And then in the case of CephFS, of course, you are attaching, it goes out and provisions your CephFS file system that gets provisioned and attached to your Sahara instance as well. A different method, but yep. What's new in Newton? So there's been a lot of development going on with Manila. Manila is very, very active. There's tons of things going on, lots of changes, and very early on they made lots of changes to the underlying architecture of Manila, which allowed for much more scalability. Things like consistency groups, which played a big role into availability zones and really being able to scale out and have high availability for your NFS shares. These were kind of some key features that needed to change and evolve. And quite frankly, they're still evolving in some ways. A lot of the availability zone functionality is still receiving lots of improvement. But it is getting better over time as we have more and more contributors from NetApp and from Hitachi and some of the other big players in the storage space. That's getting better and better. And quite frankly, in upstream OpenStack itself, availability zone technology is still being worked on. It's still in a lot of flux. And there's lots of things that are changing there. So that kind of changes some of those features that go into Manila as well. So things are still evolving in that realm. So these are all a conglomeration of all the features that have come from the previous versions on up to Newton today. Things that are new in Newton, what I have listed out here, snapshotting instances from admin APIs. This is something that the drivers themselves can take advantage of, not something that's directly exposed to the Horizon dashboard itself. The Horizon dashboard is somewhat limited to some of the functionality relating to some of the NetApp driver and some of the generic drivers. More common functionality across drivers. So you won't see some of this stuff in Horizon specifically. You will see extending shares and shrinking of shares as well. But this one, more importantly, extending snapshots. That's kind of an enhancement. That's not yet exposed in Horizon, but you will see stuff like extending and shrinking of those shares that is exposed there. So most of the time you'll see a lot of the APIs extended in Horizon a little bit later. as some of the other drivers start to adapt and adopt some of these new features. Scheduler improvements for thin provisioning, access list API. These are enhancements to the multi-tenancy. The port binding support, that was important for availability zones, for more scalability there. Let's see. And then share migration. That's also another feature that has also been improved much to keep on par with what's been going on with availability zones as well, because they kind of work together. And let's see what else. Share replication, still labeled as kind of experimental. Most of that code actually works fairly well. And it's continually being improved upon. That's one that has some tiebacks to consistency groups as well. And there's been some talk about improving and or changing some of that code in the way that works. So that's why that's really kind of experimental, because it's not, I don't think it's really deemed as kind of finalized much in the community. Any other questions on some of those new features in Newton? For core functionality, for the most part, things work quite well with Manila. Yeah, Frank?
Can you give an example of where the snapshot, and what is the use case for that right now?
That comes into play when you start to use things like containers. The snapshot functionality allows you to take a snapshot of a file share and then reuse that with another instance running in your tenant, or you can actually reuse that in another container, possibly. So that snapshot functionality becomes really, really a popular thing. You could even use it for backups.
So
Yeah.
how do you monitor the snapshot growth?
How do you monitor the snapshot? Say that again.
Because it will be growing once the main file is growing, right?
How do you monitor the snapshot growth?
Yeah.
Right. Say that again.
No, I was saying snapshot multiple instances of snapshot.
Right. So you would monitor that through the Horizon dashboard. When you take a snapshot, those snapshots are visible. As far as the usability of the storage on the NetApp server, you would monitor the...
So how often do you take a snapshot? Or do you rotate the snapshot?
Oh, that's completely up to you.
Up to you,
I mean, this
yeah.
is not something that you would automate within the framework, although you could. From a NetApp perspective, you could automate doing snapshots. But from the Horizon dashboard, this is not something that you would automate there.
But you would see them, like Cameron said, you would see them as different versions or different snapshots
Correct.
in one view.
Mm-hmm. Yeah, they're completely visible within the Horizon dashboard. So you log in as your tenant, and you can see your file shares. You could take a snapshot of a file share, and that would be visible within the dashboard. Share instances, just a little bit of detail on share instances. So this is a feature that's needed for things like share migrations and share replication. And this code hasn't really changed too much, but this allows you to have multiple share instances within the NetApp framework, and it works only best with the NetApp driver itself, keeping an active and an inactive state so that when you do migrations, when you have availability zones, you have an active and an inactive state that it can actually migrate to or do replication from. So it's a feature that's needed for these other features, to enhance these other features. And then, of course, share migrations. allowing you to share your share to be migrated from one host pool to another. And this could be between availability zones as well within OpenStack. That's been fully tested with the availability zone code. The fallback approach with that is using rsync, but that of course is very slow. You definitely want to take advantage of share migrations because this will be directly on the NetApp hardware. So much quicker that way.
Yeah, performance is much better from what we've heard as well. That's a classic use case for NetApp drivers.
Right, yeah, you don't want to use the rsync fallback. Okay. Availability zone capabilities, of course, this has been looked at from very early on. This will give the ability to integrate Manila with multiple availability zones within your OpenStack infrastructure. And most OpenStack implementations today, quite frankly, not a lot of them in production deployments, not a lot of them use availability zones. And it's really just all because of the flux there in the community and what's going on with availability zones. A lot of that code, some of it's kind of being redone. And some of it is actually, we've got new ideas on how to implement an availability zone. And so you'll see a lot of production deployments today with OpenStack where you probably won't be using availability zones, where you'll have just multiple clusters of OpenStack instead of having an availability zone. So in this case of using NetApp, you would then attach a NetApp storage cluster to each OpenStack instance that you're running. Although you can do availability zones, it's just that code is constantly changing. So we'll see what happens here in the future with that. And then, of course, the little diagram up there, the eye chart, you might not be able to see it there, but availability zones have several different ways to break that down within each zone. You have a region, and then each region might have multiple cells. In each cell, you might have various host aggregates, which are different farms of compute clusters that have different capabilities. It could be speed, it could be, different size of storage, various things that could make each aggregate, host aggregate different in its own right. State of the art for share replication. Share replication is really a functionality directly running on top of the NetApp cluster. So this will be a high-performing replication that happens from one availability zone to the other directly with NetApp clusters itself, being able to fail over to an availability zone. So essentially, if you had one OpenStack cluster over here, maybe it was in New York City, and you had another OpenStack cluster that was in California, you could possibly do share replication between those two clusters. Okay. The LVM driver. This is the simplest reference driver available within Manila. We don't recommend running this driver in production, but if you want to play around with Manila in a proof of concept environment that's really small, this might be the way to go, and you don't have a NetApp environment to plug in. You can play around with Manila using this driver. Now, this isn't the only reference driver that's out there. There are others that are other generic drivers. SUSE supports the LVM driver. There's other generic drivers that we don't support that you could use if you wanted to play around with it. Some of them don't perform very well. That's why it's not great for production deployment. Some other ones that we do support are the CephFS back to a Ceph storage cluster. The trick is with that is that the SVN that gets spun up for using these other reference drivers is that it gets spun up in the cloud. And so you have an SVM that's in the cloud, so you're actually communicating from your instance that's launched in your tenant that then communicates to the SVM that's running in the cloud back to whatever storage it is that, that you're connecting back to. Not always the best on performance, depending on your network overlay in your cloud. If your network overlay is not set up for good performance, then you're not going to get good performance using some of these reference drivers. Which is primarily why we default our stuff to using NetApp as the back-end infrastructure for Manila, because it does perform better. It's just by design on the way that the Manila driver is set up that way. But if your overlay network is state-of-the-art and you've got a really great setup, that might not be the case for you. So just kind of evaluate where you're at there and how you're designing your OpenStack infrastructure.
Cameron, I just want to add there that for people who don't have NetApp, who'd still like to at least see how it works or if they want to play around with it, I can have some business cards here. You can reach out to me, or either way, just go on the Git.io website. I think there's a link in the end. It's a website called netapp.io. And it has links to lab on demands that we offer to our partners and customers that you can go in, and it can be spun up on Amazon, AWS, which we pay for. I think about 4 hours is covered. And also lab on demand instances that you can spin up to play around with NetApp and OpenStack.
And we have a demo environment as well. Our sales engineering staff.
Yeah, SUSE has one too.
We have a demo environment. If you want to see a live demo of SUSE OpenStack Cloud connecting directly to a NetApp infrastructure, we can show that to you. That's something that's interesting. Yeah.
Maybe you could just clarify a bit more. I need to admit I don't really understand the role of NetApp and all this. Does this mean if I want to use advanced features, I need NetApp storage in NetApp hardware?
Not every driver in Manila is enabled for some of these advanced features. The capabilities the possibilities are there. However, shared replication is strictly a NetApp thing. Okay, so some of these features that are in the core of Manila are not all available for every single driver. So take, for instance, some of the Hitachi work that's been done. Their replication methodology is actually using share replication. So they've actually adapted, or in other words, adopted that functionality for their back-end storage. So NetApp put it in there, they've adopted it.
Manila is all open source, so the answer to your question is no. It doesn't necessarily need to be a NetApp hardware. It's a Manila driver, except that if you use a NetApp driver on NetApp hardware, as Cam said, there are certain features that we've added that will give you better performance. But that said, the LVM, the generic drivers of Manila still hold and are open source and free for you to use and download from openstack.org.
So this reference driver here, LVM, it doesn't have share replication. You can't do that. That won't work with this driver. So, yeah, pick your driver. They won't necessarily have every feature, but you can get a rundown of some of the feature and functionality from some of the documentation websites, and I'll reference that at the end. Okay. Some production considerations. Just as I talked about, generic driver, unstable, not cut for scale. And And that's not by design, it's just there's not been any major consideration by some of the hardware vendors to actually really try to make that better for scale. And quite frankly, it's just some of the way that it's designed with Manila, it just doesn't perform well, you know, unless you're using a hardware platform like NetApp that plugs directly into the infrastructure. So some of the core versus experimental and micro-versioned APIs, some of the things that are deemed as experimental features, consistency groups, yeah, that's constantly changing. It is in a state of flux, which really affects a lot of what's happening with everything else below that. Consistency group snapshots, share migration, and share replication. It's still something that is in the community that NetApp and Hitachi and some of the big players that are contributing there are still trying to make a decision or direction on. I think they've kind of settled on, you know, a lot of what the code is consistently doing right now, but it could change because they really want to add more features, but the way that consistency groups are working today may not work with some of these new features. So they may need to change the way that consistency groups are working. Works well the way that it is now, right? It's just upstream community. It may change in the future. Newton share driver work. Some new drivers. So the newest driver, which is interesting because this before Newton, there was a driver in Mitaka. There was a driver there that was it was called a container driver, and then they've pulled back on that, and it's been now redone, and now it's called the Docker driver. So that was released in Newton. Then we also have the Tegile IntelliFlash. I'm not sure of anything around that one, quite honestly. The Hitachi HSP, that stuff is very new. Exenta Store, also very new. It's interesting to see now we get other large hardware vendors contributing now to Manila, which is really quite neat to see. This did not happen early on.
Right.
So it's neat to see everybody else starting to adopt Manila now. Yeah. So you get a lot more flexibility in your choice. So if you do have Hitachi in your data center now, it's you know, that you have that as a possibility. And then of course we also now have the CephFS was there before, but now this is also one that we fully support now with SUSE OpenStack Cloud. It's now as a native driver, and we fully support that. EMC is also doing a little bit of work there with their Unity driver, which is basically added in as a plugin, which is a different approach. So it doesn't really spin up an SVM. So it directly plugs into the Manila, which totally different approach. So if you do have some EMC, that's a possibility. Let's see what else. And then there's various other ones.
We have 5 minutes left.
This list of drivers that you're showing there, do these enable Manila features, or
these are plugins? Yeah. These are other ways to actually have a file share to this other back-end storage.
Right.
Yep.
We have 5 minutes left.
5 minutes left. Yeah. Okay.
4 actually.
Let's see. Kala for containerization of OpenStack services. There's some integration going on there. Ganesha enhancements. This is more for NFS. There's some Red Hatty things with OOO. Let's see, more Docker stuff. Let's skip into SUSE OpenStack Cloud and some things going on here. SUSE OpenStack Cloud 7, soon to be released. So we've had it fully supported both in version 6 and version 7, which is great. Other distributions out there have not had Manila supported. We have full deployment integration with our Crowbar deployment tool, and it's also highly available in our control plane from the very beginning, which is quite awesome. So let's actually dig into that just really quickly.
Yeah, I know you really wanted to show the demo, so.
I do want to show the demo, but it's not playing.
You have to hover over the play. Yeah, here.
There it goes. So this is the dashboard for Crowbar, and what we're going to show here is the bar clamp. Bar clamp is deploying Manila specifically. This deploys Manila into your control plane, and we're going to make it highly available. And he's selecting NetApp Driver. You probably cannot even see that. That is really bad. But he's putting in the back end. So this is the host name of the server that he's connecting to, and then some other parameters. And then there's the port that he's going to connect to as well. And the username and password for the NetApp infrastructure. You can do secure, non-secure, and then he's deleting that generic driver backend. And you can actually add in multiple backends and then add in parameters. You can actually put in more parameters if you want to put in another generic driver. You could do that as well and put in custom parameters for that generic driver. But we're not going to do that here, so we deleted that. We're going to add in the cluster for your control plane, and then also the nodes, the compute nodes in which Manila will be available on. And then we click apply, and this will deploy it within the infrastructure. Really quite easy. So this will actually make it highly available on the control plane, so it will integrate with our pacemaker infrastructure, and it's really very quick. This here is the Horizon dashboard within OpenStack, and this is creating a share type of NFS for Manila. And there is multiple share types that you can actually deploy, and now we'll actually attach that to an instance. Actually, no, this is creating another share within the instance here. And there we go, it's creating the share. Okay, we have the share created. And there we go. Just a small demo. If you want something further, we could show you some of the integration steps that are required on the NetApp side. We could show that to you in our sales engineering lab.
And there is a hands-on demo, by the way. Yeah, I had somebody in the booth stop by and ask me and talk to it about that there is a hands-on demo in Manila with SUSE as well that I think you can do here.
And just to skip ahead really quickly, here's some of the links I was referring to earlier if you wanted to take a picture of that. These slides will be available for download as well. And so if you wanted to get involved or look up more documentation on some of the features that I talked about today, you can visit some of these links. And that's it. Thanks for coming.